Epicon tutorial.
Today, we want to learn how to calculate Adomian polynomials for nonlinear terms in a differential equation. So we start by looking at when n is 0. So when n is 0, our an becomes a naught equal to 1 over 0 factorial the x raised over 0, then into n u. So and this gives a naught equal to n of u naught. So that's when n is equal to 0. So that's how to calculate the Adomian polynomial. Then for n equal to 1, we're going to have a1 equals to 1 over 1 factorial dx into n. So for here, our I begins from 0 to 1. So we are going to consider when I is 0 and when I is 1 for u, I, x, I. So when I is 0, we are going to have u naught x naught plus u1 x1, or let's just say x. So here, our a1, so it means we are going to differentiate these ones, that is n into u naught plus u1 x will be differentiated. So differentiating that, if we differentiate this, it's going to give us u1 n prime into u naught plus u1 x. So at x equal to 0, our a1 gives us u1 n prime into u naught. Then let's also consider when n is equal to 2. When n is 2, we have a2 equals to 1 over 2 factorial d square dx square n into, so for this now, our n is 2. So that means our I will be, it will run from 0 to 2 when I is 0, when I is 1, and when I is 2 for ui x. So we obtain the following terms: u naught plus u1 x plus u2 x squared. So differentiating this one twice, our a2 will yield u2 n prime u naught plus 1 over 2 factorial u1 squared n prime of u naught. So now, our results can be written as this. So for a naught, we have n u naught. For a1, we obtained u1 n prime of u naught. For a2, we have u2 n prime of u naught plus 1 over 2 factorial u1 squared n prime of u naught. And then we can as well obtain the when n equal to 3 and so on. So we want to apply these results to some specific examples. So let's look at a situation when we have different nonlinear terms. Suppose our nonlinear term in a differential equation is equal to u squared. So our a naught can be calculated as a naught equal to n of u naught, n u naught, which is u, and our u naught is u naught squared, so u naught squared. Then for a1 here, our a1, we said we apply u1 n prime of u naught So this would be u1 n prime of u naught squared. This gives u1. So we differentiate our u naught once, multiplied by 2 u naught. So a1 is 2 u naught u1. So let us attempt a2 here. A2, we obtain the expression for that as u2 n prime u naught plus 1 over 2 factorial u1 squared n prime prime u naught. So in that case, it's going to be u2, so n1 n prime u naught squared plus 1 over 2 factorial u1 squared n prime prime of u naught squared. So differentiating here, we have u2, we differentiate once times 2 u naught plus 1 over 2 factorial u1 squared. So here we're going to differentiate twice, and that gives 2. This cancels this. So our a2 is going to be 2 u naught u2 plus u1 squared. So one thing we should observe here is that when the subscript of our a is not, then the total subscript here too is 0. For a1, when the subscript is 1, the total subscript here is 1 plus 0, which is 1. And then for a2, the subscript here for this first term is a 0 plus 2, which is 2. And here this is u1, which is a 1 plus 1, 2. So the subscript for each term must agree with the subscript of our a. So that's about u squared as our nonlinear term. Suppose our nonlinear term is suppose we have a sine function such as sine u. So for a naught, this will be n of sine u naught, which is sine u naught. No differentiation here. For a1, this will be u1 n prime of sine u naught. So here we differentiate sine u naught once. So differentiating that gives us cos u naught. And then let's quickly consider a2 here. Our a2 is going to be u2 n prime into sine u naught plus 1 over 2 factorial u1 squared n prime prime sine u naught. If we differentiate, simplifying this, we obtain u2 cos u naught. So this is differentiated once. 1 over 2 factorial u1 squared. So we're going to differentiate sine twice, and that gives us negative sine u naught. So finally we have a u2 cos u naught plus minus 1 over 2 factorial u1 squared sine u naught. And finally, we look at a situation when we have our nonlinear term as exponential u. So when our nonlinear term is an exponential, so for a naught, that will be n exponential u naught, which is no differentiation, exponential u naught. Then for a1, we have u1 n prime exponential u naught. This will give u1, differentiating that once, to give us this. And for a2, that will be u2 n prime exponential u naught plus 1 over 2 factorial u1 squared n prime prime exponential u naught. So this gives u2 exponential u naught. We are differentiating exponential u naught once factorial u1 squared exponential u naught. This can be written as a u2 plus 1/2 factorial u1 squared exponential u naught. So these are the various applications of this expression to calculate Adomian polynomial for nonlinear terms. Thank you for listening.